and welcome to our symposium today on creating healthy livable cities from why and what to how, the journey of research program. My name's Billie Giles-Corti and I'm the director of the Healthy Livable Cities group, and it's a real pleasure to welcome you today. Before commencing, I would like to acknowledge the traditional owners of the land on which we're all meeting in Melbourne. It's the Worong and Burong language groups of the Eastern Kulin Nations, and I'd like to acknowledge their as the traditional owners and custodians throughout Australia. We recognise in our group that the ongoing unceded sovereignty that they have to the lands and waters on which we do our work, and we'd like to acknowledge the wisdom of their elders and ancestors in caring and protecting country over millennia. Oh, it's a busy program today. We're going to walk you through the whole program of work that we've been working on, or a subset actually, not all of it. I'm going to give a brief introduction. We're going to talk to you about how we have tried to empower policymakers and researchers, and this is Carl Higgs. And we're going to move to from what and why to how, and we're going to be presenting our modelling work and simulation work. Alan Both, Dhirendra Singh, Afshin, Jafari, Mahsa, Abdollahyar, and Steve at Pemberton will be presenting that work. And then Lucy Gunn will be talking about valuing the city. We're very fortunate to have a terrific panel, and I'm going to introduce you to them later in the session. Lucy's going to have run the Q&A session, and then I'll do a wrap up. So that's the proceedings for today. I'm going to first give an introduction about how we came to do this work, and that started way back in 2010, before I came to Melbourne actually, and Ian Butterworth, who was the director of health of the Northwest region of Health Department program, he asked us if we could work with his team because there was so much growth going on in the area. In fact, the Northwest region of Melbourne was experiencing about 2% growth per year, and it was putting a lot of pressure on infrastructure and amenities, and this was putting pressure on local residents. So working with the department, we came up with a definition of urban livability, and we did that through a health lens. And with funding from the NHMRC and a Centre for Research Excellence in Healthy Livable Communities, we developed a program of work which was led by Hannah Badland, where we asked the question, are the underlying domains of livability associated with health and wellbeing? We looked at 7 different underlying domains of livability, and she and the team put together a whole program of work where we found out indeed these are associated with health and wellbeing and really important to include in our livability work. We then upscaled this work with funding from the Prevention Centre. So first of all, we started off mapping this work in Melbourne, but then with funding from the Prevention Centre, we upscaled this work and went nationally. In 4 capital cities, Perth, Melbourne, Sydney and Brisbane, we developed livability work. We mapped and looked at the spatial distribution of livability domains. And we also did, with funding from the Clean Air and Urban Landscapes, we also undertook policy analysis and asked the questions, do we have the policies in place to deliver healthy and livable communities? The question was, no, we don't. And then we wanted to upscale and empower decision makings. And to do that, we took the data off our computers and made it available for policymakers. And this was launched in 2020. Through the Australian Urban Observatory was born, which was fantastic. And then we put out scorecards for the 21 cities. We had livability indicators for 21 cities that were in the National Cities Performance Framework. Now, we took this work globally over the last 3 years, and we've gone global. We've got 80 collaborators, 25 cities, 19 countries. So what we did in Australia, we've upscaled that to go global, and we just recently launched the Lancet series, and we've created a global observatory of healthy and sustainable cities where we're hosting all of our scorecards for each of the cities that were in the studies, 25 cities in the study. And then now we're moving further forward because we want to actually change the way we build cities. And so we're going from the what and the why to how, and what impact will we have if we changed our cities the way we planned our cities. And this is agent-based modelling work, which is and simulation work that's going to be presented what would happen if we put in separated bike paths, and how will that change people's behaviour? These are the sorts of questions that we're addressing with this work. So it's very exciting work that we've got. I would like to acknowledge before we start the many partners, particularly from the Australian Prevention Partnership Centre, the Prevention Centre, and all the contributing partners who've contributed funding to the two TAPs. And also I'd like to acknowledge all the very many people who have contributed to the work that we've presented through our livability work, long-term program of work that's been undertaken by our team. I'd like to acknowledge them before we move on. And as I do, I want to now hand over to Carl Higgs. He's a doctoral research fellow at RMIT in the Centre for Urban Research in our Healthy Liveable Cities group, and he's going to be presenting about how we've gone from local to global and made a difference with our spatial indicators. So I'm going to hand over now to Carl.
Thank you, Billie. Urban environments shape our lives, and an increasing majority of us worldwide are city dwellers, and the design of the neighbourhoods where we live influences our choices to walk or drive, to get our groceries on the weekend, to see friends in a nearby park or stay at home. Across our lives, where we live influences how we get to work, whether and where we study, if we can get to health services when we need them, and how we spend our time in nature or with friends. We know that these choices and opportunities have implications not just for individuals and population health, but also for our planet. So how do we leverage this knowledge to build healthier, more equitable and sustainable cities? My name's Carl Higgs, and I'm a doctoral researcher in the Healthy Liveable Cities Lab with a background in spatial epidemiology, and I've been involved in the scaling up of our National Livability Indicators program across the past 6 years. I'm going to share with you how we've designed our work with the support of the Prevention Partnership Centre to put actionable evidence in the hands of communities, policymakers and researchers to move from understanding to action in Australia and internationally. Our experience of cities is about more than their central business districts, but this is the narrow view of urban experience often reflected in the livability city rankings we see in newspaper headlines each year. Our experiences with the COVID pandemic these past few years have emphasised the importance of the delivery of services and amenities within our local neighbourhoods. At a basic level, can we walk to these, or do we need to drive? And what does that mean for our health and well-being? Fundamentally, our livability program has aimed to measure and monitor inequities across cities to better understand the impacts of these and empower decision makers with the evidence needed to enact change for the better. We identified a suite of policy relevant and evidence-informed indicators, which had been found to be supportive of health and well-being, encapsulated in our definition of a livable neighbourhood, which has been broadly adopted, including in the Victorian Department of Health's Public Health and Wellbeing Plan, and informing Plan Melbourne's concept of a 20-minute neighbourhood. And we designed a generalised process to create these measures at scale for different cities and urban contexts, using available data, which we analysed to produce outputs, which are useful for a broad range of stakeholder needs, from high-level summaries and reports, to interactive maps, to granular data for linkage with individual participant health outcomes. By starting with granular address-level measures, we could aggregate upwards, linking small area estimates with counts of dwellings and the resident population, to estimate, for example, how the percentage of people or dwellings with access to a particular amenity, like a supermarket for fresh food, varies across a neighbourhood, suburb or a city. And then get overall statistics for neighbourhoods, suburbs, local government areas and cities for comparisons between as well as within cities and other area scales. The Australian Urban Observatory, our interactive map portal for Australia's 21 largest cities, was designed as a visual tool for exploring livability and its underlying determinants, which we measured using this method. You can search for a particular suburb and view a summary profile of livability indicators, and then drill down, visualising how a selected indicator, in this case, the Urban Livability Index, varies across according to neighbourhoods within that suburb, and relative to areas of that scale across the rest of the city. Using a satellite-based map also allows you to evaluate visually how the variation relates to the underlying urban fabric. The Urban Observatory contains more than 40 indicators summarised at neighbourhood, suburb and local government scales, encompassing topics including food, housing, employment, public open space, social infrastructure, transport, walkability and overall livability. With the support of the Prevention Partnership Centre and other funders, we've scaled up our measures of urban livability far beyond the initial Melbourne pilot study of 1.5 million urban residential address locations. The methods were extended for Australia's capital cities, with results published in the Creating Livable Cities report and scorecards, and then further applied for major regional cities and local government areas around Australia in our national study. Across the past 3 years, the results from the Australian National Livability Study have informed a broad range of further research, tools and reports, with examples including research investigating the impacts of the built environment on early childhood development, ageing, disability, as well as usage in large-scale simulation studies and agent-based modelling, like those which my colleagues will be discussing later today. In addition to supplying indicator data made available through the Australian Urban Observatory, we also prepared downloadable scorecard reports for capital and regional cities, and further reports using this data have been prepared for local governments around Australia. Additional livability and sustainability related indicators were prepared for the Department of Premier and Cabinet's National Cities Performance Framework. And finally, a database of livability indicators for more than 6 million Australian urban residential address locations will be made publicly available via VicShare upon publication of our forthcoming data descriptor manuscript. More recently, we've extended these methods to cities internationally through the Global Healthy and Sustainable City Indicators collaboration study, which was recently published in the Lancet Global Health series on urban design, transport and health. We developed open source software for measuring and reporting on livability indicators across diverse contexts globally using open data. And we also developed open source software to support publishing the results as scorecard infographics and reports of health-related policy and spatial indicators of urban design and transport features in multiple languages. We engaged with local experts, collaborating on the translation and contextualization of our research, resulting in 46 bespoke reports for each of the 25 middle and high-income cities included in the study across 16 languages. The walkability of Australian cities didn't compare well with many global cities, including those from middle-income countries, due to our sprawling car-dependent urban growth patterns. But pathways for improvement for each city were also identified through policy checklists and city-specific executive summaries. These resources were prepared for each city in consultation with local experts and include checklists, graphs and maps, all of which are available from healthysustainablecities.org and on VicShare. The resources and study findings have been used as a catalyst for local town hall events in cities around the world, bringing together community advocates, local planners, policymakers, mayors and researchers to discuss what these results mean for their cities and identify which actions are needed to create more health supportive and sustainable neighbourhoods. We have an ambition to scale this further through our 1000 Cities Challenge, and through my PhD, I'm working with our research network to further expand our software and tools to better support this process in line with the principles of open science, so we can continue to improve supporting communities, policymakers, planners and researchers to shape our urban environments for the better. Thank you. And I'll now introduce Dr. Alan Both, who will be presenting on our work around relating to employment across Australia. Thank you, Alan.
Thanks, Carl. Hi, excellent. So hi, everyone. I'd like to provide you with a brief overview of our analysis of the feasibility of achieving 30-minute cities within Australia. So firstly, a bit of background. 3/4 of all Australians live in one of the 21 cities shown here. So these are our major capital and regional cities. And as Carl said, the Australian commute is very car dominant. So it's often our longest daily trip, and almost 80% of us make it by using driving. So in addition to the health costs of such a sedentary commute, the congestion of these trips have a yearly fiscal cost of $16.5 billion. So one solution to these problems is a 30-minute city, which is a place where most people can access employment and amenities within a 30-minute trip. The 30-minute city isn't just about living and working locally, but living healthily. As such, it focuses on using active transport, such as walking, cycling, and public transport for residents to reach their destinations. I'd like to acknowledge my co-authors for all of their contributions to this work. I'll only be doing a brief overview of our work today, but I've included a link to the full paper here. It's open access, so it's available for free for anyone to download. So what did we actually do? Well, we started our analysis by looking at Vista Commute data. So for those of you who don't know, Vista is the Victorian Travel Survey. It's about 0.1% sample of people, of Victorians' daily commutes. And here I've graphed a breakdown of commute distances by mode. So the horizontal lines here represent our cutoff for a 30-minute trip. And an interesting thing to note here is the one for driving, which is at the bottom, is very close to the average commute distance from the Australian census. So I think it's no surprise that walking trips tend to be shorter and driving trips tend to be longer. But what I'd like to point out is that there are a lot of very short driving trips. So as you can see here, a lot of these very short trips could potentially be switched to another mode, such as walking. Now, cycling is a much faster mode for obvious reasons. So there's actually even greater potential for mode shift. So we can see here all these driving trips could potentially be moved over to cycling. Another interesting thing to note is public transport is very flat, but these trips tend to be actually quite long. So the average commute time for a public transit trip in Melbourne is actually about an hour. So this led us to a couple of research questions. So first, we wanted to create a baseline to see where we're currently at achieving the 30-minute city. Then we wanted to look at mode shift to see if people did shift their modes to a more active transport, what percentage could actually achieve the 30-minute city. Our third and most ambitious mode was our third and most ambitious research question is about job worker shifts. So what we want to see here is if people were to move closer to their employment or if we were to relocate employment closer to home, would we be able to achieve a 30-minute city? So how do we actually do this? Well, we took the Vista travel surveys that I mentioned before, and we modeled commute speed. So this allowed us to then convert the census journey to work times into journey to work distances into travel times. From there, it was possible to calculate the baseline and mode shift measures. For job worker shift, we attempt to minimize the total commute distance by matching workers to jobs. So here we can see a set of workers in their homes and a set of jobs in the middle. Currently, commute distances are fairly unoptimized, so we see some commuters travel short distances to work, whereas some travel very long distances. If we're to use an algorithm, we can actually reassign these commutes so that the total overall distance is minimized. So what we can see here is some distances are a bit longer, but overall the total distance is shorter. Now, in this example, all jobs are interchangeable, but for our analysis, we actually performed this procedure 15 separate times for each of the 15 major job categories. Well, here we go. Now, so what does this look like? So if we look at the travel times for commuters, we see a few things. Again, I've plotted these horizontal lines to represent our 30-minute cutoffs, but this time I've plotted travel time to work. So the first thing I'd like to draw attention to here is that there's a moderate growth in walking for mode shift, but substantial growth for cycling and public transport. And this is mostly because these two measures are much faster. While cycling and public transport perform well, cycling is actually slightly faster because it performed because for short trips, cycling is just a faster mode because there's no interchange. So it will score slightly better. And I've just highlighted that there. It's a little hard to see, but you can hopefully see that cycling is performing slightly better there. In terms of the job worker shift, there's actually a substantial increase here. I've plotted the so the axes on the bottom graph there is a lot shorter, so there is actually quite a lot more going on there. So what does this look like in a more tabular format? Something like this. So what we found is that while public transport currently performs the best at achieving a 30-minute city, it's not that substantial. We're only at 3.4%. If we are to look at people shifting mode, we find that cycling performs quite well. So almost 30% of all Australian commuters today could reach their work within 30 minutes today if they're to start cycling today. If they were to move closer to their job, or if they were to take a job that was similar but closer to home, that percentage moves all the way up to 70%. Now this is quite a substantial number, but it is aspirational. So the idea here is to show that under the most optimal circumstances, could we achieve a 30-minute city? And from this, we can see, yes, we can. And what's important to note here is that not only is it indeed achievable using our current housing and jobs, our current locations of our housing and jobs, but it's achievable today. So there's perhaps worded that a little bit awkwardly, but what I actually wanted to say was, assuming that we don't build any more new houses and we don't shift jobs to new locations, 70% is our best, is our most optimal answer for a 30-minute city today, which is quite substantial. So I think where to next is something to consider. And really what this has shown is our sort of upper bound of what we can hope to achieve with a 30-minute city. But if we're to actually achieve that, we need to do more work. And for that, we need to do more in-depth simulations of how people get to work, how they move around the city, how our infrastructure looks. And for that, I'd like to introduce our principal research fellow, Dr. Dhirendra Singh, who will be talking about our simulation work. Thanks.
You're on mute.
Thanks, Alan. Thanks, Billie. Okay, so I want to talk about simulation and this idea of creating a virtual lab for testing real-world interventions. Okay, so let's start with what we mean by a virtual lab. So here's an image taken from VicRoad's concept video of protected intersections for cyclists. You can see it's a virtual world with people going about their day. And the question we might have is, how will commuters respond to this built environment intervention, this green intersection? Will more cyclists come this way because it's safer? Will it encourage more cycling? Will there be other benefits, like maybe it will entice walkers as well? Will there be any negative effects? Will motorists try and avoid this intersection maybe? And if so, where will they go? And what will that do to traffic elsewhere? And what if we took this intervention and applied it citywide? What would that do to commutes? So the idea with the virtual lab is to build a virtual representation of the real world in which we could test out the impacts of planned real world interventions. Okay, so how do we do this? The first step is to model what we call the supply, which is the destinations of interest, workplaces, shops, etc., and all of the infrastructure that links them together. So roads, public transport, and such. We then model the demand, the population, or the individuals, and what they want to do, where, when, why, for how long, using what mode, and what influences all of their choices, i.e. the behavior model. The third step is to make this demand fit the supply. And we do this using simulation and to try and match such that this synthetic world mimics real world observations, such as traffic flows through the day. Now we have a virtual lab. And so if we want to now test some interventions, we would then change the supply hypothetically, such as through our proposed intersection, and see how the demand then adapts to this change. One final point to note, these are complex models, but nevertheless, they still simplify reality. And so when looking at the results, one should always remember the simplifying assumptions these models are making. Okay, so let's look at the first three steps in a little bit more detail. How do we model the supply? We start by taking a representation of the road infrastructure using OpenStreetMap. To this, we add any missing information, such as public transport details. And then we simplify this network in such a way that the results of travel times and distances are still pretty accurate, but the network graph itself is much smaller and therefore much faster to run traffic simulations on. So in this picture on the right, you see in blue our simplified network, and in gray the real underlying network for an area around the Melbourne CBD, giving a sense of how geometries are simplified in this case. Okay, in modeling the demand, the people, the process is to create virtual people. We start with census data and add virtual persons to street addresses as per the demographic profile of the statistical area. We then assign to each person a daily travel itinerary, similar to activities and trips seen in Vista, the Victorian Travel Survey. And finally, we calibrate this model to match on activity start and end times, durations, origins, destinations, travel modes, and such. Fine. And it's also here important to note that every individual is being modeled. So thinking back to my first slide, each of those individuals, the demographics, trips, choices, is all included for all of Melbourne. Okay, in matching the demand to supply, like I said, we do this through simulation in a virtual world. So we simulate the daily travels of all the people in this virtual world, and then we score them on how they went in their day. So for example, people who got stuck in congestion, let's say in the simulation, would have performed poorly. And we then modify the plans of the people who scored poorly so that they could try something different. Maybe they leave work a little bit earlier, or maybe they leave home a little bit later in the morning. And we repeat this process of simulation over and over until the scores of the entire population sort of increase and saturate, and the scores have now stabilized. So we call it at that point that some sort of equilibrium has been reached. So this represents how we believe the demand, the synthetic demand, adapts to the current infrastructure. Okay, I'll just give you a little demo of what all of this might look like. Okay, so here's in the background was a map of the real world, and the black is the overlay of the simplified road network. The green triangle you saw was cyclists going in the daily commutes in the morning. The red lines you see, they're itineraries of these travelers for the day, stopping at different destinations like study and work locations. So like I said, this is an agent-based model, so every individual is modeled with their daily plans. Now, I've only just shown a couple of agents, but in our testbed, we have virtual persons for all of Greater Melbourne. Okay, with that, I will now pass to Afshin Jafari, who's a research fellow in the Healthy Liveable Cities Lab, who will now talk about how we use this model to test citywide cycling interventions.
Okay, thank you, Dhirendra. Yes, as Dhirendra said, I'm going to talk about The work that I did as part of my PhD research in this project on extending the model that Dhirendra explained and including some cycling components to that, and also use that to test some citywide cycling intervention. But before getting into the model details and results, one question is why we needed to do anything extra, why we needed to extend the simulation model for cycling. And the answer is that when you are on a bike, you interact with your environment and other road users and the natural environment and everything much more than when you are sitting in a car or sitting in a public transport vehicle or something. So that for that reason, there was a need to expand the model to include more factors impacting an agent's travel behavior compared to a baseline model for car and public transport use. With that said, in this study, we only included built environment factors and selected demographic factors. There are other factors such as social factors and also weather and others that we can also include. I will talk about this later in my final slide. Another question was, what about in Melbourne? Like, what is it exactly in Melbourne that people care about when they want to decide to use a bike or not? And to answer this question, we looked at travel survey data for Victoria, and we looked at people who chose to use bike versus people who didn't. And it turns out gender, age, employment, being employed or unemployed, population density, intersection density, which translates into connectivity, and bike bay density and elevation variation, hilliness of the area, they were all found to be important for a person's decision to use a bike or not, based on what they reported in the travel survey. Another question that we looked at before getting into the simulation model was what are the factors important for having more cyclists on this road segment compared to the other one? So what are the factors with correlating with cycling volume on each road segment? For this one, we used the Strava Metro data, and we found that for both male and female cyclists, cycling on a road leading to a non-signalized roundabout was less likely compared to cycling on a road leading to a non-signalized intersection. Cycling on a shared path was less likely or compared to cycling on a dedicated bike path. Shared path means shared between pedestrians and cyclists. Cycling on a bike lane was more likely compared to cycling on a road without a bike lane, a mixed traffic road. And also cycling on paved rough surfaces like concrete was more likely compared to asphalt, which is usually a mixed traffic, inside the road sort of bike lane. For female cyclists specifically, we found that cycling on roads leading to signalized roundabout was more likely compared to a non-signalized intersection. And also they were less likely to cycle on unpaved road like dirt or those types of things compared to a paved road. So these details or all these findings informed us on what to include for building a cycling simulation model for Melbourne. And that's basically what we did. We started from the baseline network that Dhirendra explained and included other factors such as, or attributes such as bicycle infrastructure type, different types of infrastructure that we have, road elevation, and also junction and signal type of each basically junction. Additionally, we included different behaviors that different groups of people based on their age and gender have when they are on a bike, when they are riding a bicycle. So to do this, we started from the cyclists in the Vista travel survey. We grouped them into 26 different groups of age and gender. And we looked at how far these cyclists cycled and how long they cycled. So cycling travel time and distance of those who cycled according to Vista. So that's what we looked at. And it turns out you can quite nicely divide them or cluster them into 4 clusters based on how far and how long they cycled. So in this graph, the x-axis is travel time and y is the x1 is travel distance and the y is travel time. And this is normalized. So 0 means about average. And you can see there is a cluster of males, all males, 55 to 60, 35 to 40, 65 to 70, that are cycling long distances and long time. So we call them maverick males because just they're going long distances, and that's great. Then the second group is these cohort, mostly male. There is a cohort of female 35 to 40 here as well, but others are all male in working age, and they are going above average distances and above average travel time. We call them motivated adults. The third group is the blue one, mostly female working age population. There is a cohort of male 25 to 30 here as well, but they are mostly female. They're cycling about average in terms of travel time and distance, a little bit maybe less in terms of distance, but about average for travel time. We call them conscious commuters. And then the final cohort is, you see they don't cycle that long or that's distance that far. And these are mostly children and also female 60 to 65. And we call them relaxed cruisers because they don't really go that far or that long. And then we put all these, and then we build different cycling behavior models for each of these different cohorts. So 4 cohorts, 4 different behavior models, 4 clusters, 4 different behavior models, and also all the new built environment attributes that we added to the network. So here is a visualization of the output of the simulation model, how it all looks like when we put them all together. So you see different, these are all cyclists. This is around, this is a 10% sample of Melbourne population. So it is around the morning peak. So you can see people are coming to CBD to go to their workplaces or places of education. And we have different infrastructure here, like red lines are bike paths, blue are separated bike lanes, or greens are bike lane. And then different colors of agencies, different speeds based on elevation, surface type, and also bicycle infrastructure and all those sorts of things. Okay, so we have the model. Now what we can do with that? What do we want to understand, or what question we want to answer? One thing is that the model is a city scale model, so it models the whole greater Melbourne. And ideally, the type of question we wanted to answer with the model was also needed to be a large scale question. And we started looking at the strategies that we have in Victoria, and also we talked to a number of policymakers and planners. It turns out one very interesting strategy or intervention that we could test is strategic cycling corridors around Greater Melbourne, or SCC. So what SCC is that it is a network of connected and safe cycling corridors that aims to provide safe access for people to get to major destinations, major daily destinations using bicycle. It all sounds great and very exciting. The issue is that it is not fully completed. So it's a plan. It's not. Some parts of it exist out there, so you can see different bike lanes that are existing out there in Melbourne that are basically overlaying with are matching the SCC, but there are lots of gaps, particularly in outer and middle ring suburbs of Melbourne. There is a lot of gaps, and most of them there's nothing actually out there. So we said, okay, let's take this map, this proposed map of corridors, and see how it looks if we had it fully implemented. But if we had everything right now built on the road network, and it seems that the result could have been very significant in terms of bike mode usage or bike mode share, cycling mode share. So we can see on average we could expect about 130% increase in number of cycling or cycling mode share. It's more accurate to say if we had SCC fully implemented. And when we look at the clusters individually, you can see the highest increase we can expect for those in working age, with about 154% increase in their cycling mode share across Melbourne. But this is not the full story. The thing is, what we have modeled here is just adding one specific project or built environment intervention. But in reality, we know that if you have more cycling on the road, more cyclists on the road, they will attract more cyclists through shifting social norms or changing attitudes towards cycling, and also safety in numbers is very important factors here. So none of those are included here, and we expect that these numbers could be much higher if we also include all the other important things such as social norms and also social connections. So that's one of the potential next step for our model. Another next step could be to look at the cycling in the context of 20-minute neighborhood and how we can use cycling to get to our daily destination and to reach the goal of local and healthy and active living. Another expansion to the model could be to include more heterogeneity into the model. Like cyclists, with agent-based model, you have the ability to include more heterogeneous behavior and more different attributes in one's decision making, such as having a child or all those things you could also include in the model. And finally, another next step could be to join health impact and environment and economic impact assessment models to better understand the implications of the selected intervention. With that, I hand over to my colleague, Mahsa Abdollahyar, who will talk about another extension and intervention to the model on public transport use.
I'm Mahsa Abdollahyar, and today I'm going to talk about modeling the impacts of a major rail project on walking and public transport use. Suburban Rail Loop, SRL, is a cross-city loop through middle suburbs of Melbourne, and it contains 3 stages: SRL East, SRL North, and SRL West. And we modeled SRL East in our modeling by creating new SRL East network. What we did that we added new train stations in Cheltenham, Clayton, Monash, Galloway, Bearwood, and Box Hill. We also added new public transport links representing rails to connect these stations. We added these new stations and links to our baseline model to be able to model SRL intervention. We made some assumptions in our modeling. So for example, we didn't consider any other major infrastructure interventions like new additional public transport services. We didn't consider citywide population growth, and our population is based on 2016 census. We increased the population density around SRL precinct area, but we didn't consider other interventions like changes in land uses, jobs, or transport infrastructure. We also didn't model various public transport fares like concession or any change in future public transport fare. We also didn't include public parking capacity limitation. We considered demographic clusters, and the clustering was based on age, gender, and activities that people do during a day. We calculated the probability of having similar trip patterns or doing similar activities in a day, and we came up with these 5 clusters that perform similar behavior. And what this clustering means in our simulation is that each cluster has a specific probability of shifting mode and using each transport mode during simulation. We also modeled intermodal public transport trips, specifically for trips done by train. For example, consider someone is going from home to work by train, and then from work to shopping store by walking, and then back from shop to home by train. What we did is that we assigned and added train station coordinates to each agent trip journey. And this loop trip from home to work to shop is modeled in our simulation like this. So we basically gave our agents the ability to choose between driving and walking to train station, and then from there to use train to go to their destination. Also, each mode that our agent use in a morning for a trip from home to train station, they will use the same mode for trip back from train station to home at the end of the day. So, and we did this intermodal public transport trips to be able to capture the changes in physical activities as the result of shifting mode from driving to walking to train station. We tuned our model to the real world data, and the data sources that we used are the Victorian Integrated Survey of Travel and Activity Vista 2016 to 2018 trip data within the Greater Melbourne area. For driving, we use highway hourly typical traffic volume. For cycling, we used manual and automatic hourly counts. For walking, we use City of Melbourne pedestrian count data. And for public transport, we used public transport survey data. I'm going to show you a short video of the SRL users activity from 7 a.m., approximately 7 a.m. to 7 p.m. during a day. Each color represents different activities: light blue, home, red, work, green, study, and dark blue, other activities. And when a color light up, it means that an agent reaches the activity. In the morning, we can see that light blue dots are fading, and we can see more red color, especially around CBD. And also we can see green color around the SRL precinct area. And as we go, especially in the afternoon, we can see more of dark dots, dark blue dots, and it means that they are going to other destinations. At the end, we can see that more of light blue, meaning that they are going back home. We use the results of our SRL simulation and compare the results to our baseline model to see the changes in public transport use and walking. And my colleague Steve, who is a research officer in our team, will show you some of the results.
Thank you very much, Mahsa. I'm going to discuss some of the results from the simulation of the suburban rail loop, the SRL, that Mahsa has just described, and I'm going to do that under 3 headings. First, I'll look at the SRL users, the people that our simulation found are likely to use the SRL itself. Then I'll look at a targeted subset of trips in our simulation that are likely to benefit from the suburban rail loop and see how much they do benefit. And then I'll zoom out to look at some results for all the trips in our simulation citywide. So the first section will give a visual overview of the trips that our model did show as being taken on the SRL. Where do the people who take those trips live? Where do they go? And what mode had they used in the baseline simulation? So first, where do they live? This map shows the percentage of travellers in a given statistical area who use the SRL in our simulation. Yellow is up to 1% in an area, and you can see that people spread broadly across Melbourne are using the SRL to this limited extent. Green shows some higher clusters, 2 or 3% of travellers, particularly where there are rail lines or bus routes that feed into the SRL. And the strongest results, over 5%, are in the areas near the SRL station, with stations with the highest being around 8% in Glen Waverley. This map shows where the SRL users go. the full routes that they take, and they're aggregated so that thicker lines show routes taken by more SRL users. It's like a static version of the video that Mahsa showed. It's all the people who use the SRL for part of their trip. So note the flows that come into the SRL from the connecting railway lines, or to the north there from connecting bus routes. So for example, these are people from the east or southeast who come in on the train and then transfer to the SRL to get to the new stations, which are where Monash and Deakin universities are. Or they might be people living near the SRL who use it as part of a trip that connects with rail lines to somewhere else. And sometimes you can see in quite a distant part of Melbourne. So this map shows the SRL serving quite a diverse set of cross-city trips around Melbourne. What mode did SRL users use before? This looks at agents who use the SRL, and it shows the main mode that they had been using for the equivalent trips in the baseline scenario. We can see that around 50% are have diverted from other public transport, and we can see that around 50% had diverted from car use. Quite a good figure of diversion. Now, the second part of what I'll present, I'll move to trips that our model showed, I'll move beyond trips that our model showed being taken by the SRL. We're looking at a subset of all the trips in our model. This is a subset that we've picked because it's some that the SRL could well serve. What we're looking at here is the trips that start within 800 metres of any railway station in Melbourne and that end within one of the precincts, which are the areas in a 1,600 metre radius around the SRL stations. So this is one group of trips, obviously not the only group, one group that the SRL could be well suited to serve. So it might include, say, someone who lives in the north but travels to Monash or Deakin Uni in a precinct. And it includes someone who lives in a precinct and comes home after a day working somewhere else. We want to look at the effect that the SRL has, changes in the simulation on this targeted subset of trips. Just a reminder that under our modelling assumptions, this is modelling current trip patterns, not the patterns as they might change as a result of things like adding new jobs in the precinct. It's just the effect of current patterns. This is one target subset. We could expect much the same results if we looked at the reverse, so people going home from Monash Uni to their home elsewhere at the end of the day. So what effect did the SRL have on these trips? This shows baseline column shows our simulation without the SRL, and the SRL intervention column shows what happens when we add in the suburban rail loop. So for this targeted subset of trips, you can see that trips using the car drop by about 2.5%. That's 71 down to the 68.5. And you can see that trips using public transport or trips using active transport go up around 2.5 to 3%. Now I'll add some details of the average daily distance walked. So the average for all people in this targeted subset goes up about 11%, from about 1,250 metres walked to about 1,400 metres when we add the SRL. But when we look at the distance walked by the people who do walk, the average hardly changes. The average distance walked stays just under 4,200 metres. So that is, there is more walking because the SRL is resulting in more people walking an average of 4,200 metres, not because the same people are walking further. Similarly, if we look at the average daily time spent in active transport for the subset of trips, it goes up by about 11%, about 15.5 minutes to 17.5 minutes. But the average doesn't change. Again, it's because more people are engaging in active transport for about 50 minutes each, rather than because the same people are doing more of it. Then the third and last part of my talk, I will build up the same table, but this time aggregating all the trips in our simulation, not just a targeted subset that the SRL was well suited to serve. So across all the trips that we modelled in Melbourne, trips using the car drop by about 1%, and trips using public or active transport go up by about 1%. These are more modest, obviously, than the 2.5 or 3% figures for the target subset. Not a great surprise because this is all the trips in the simulation, some of which might be on the far side of Melbourne and not likely to be affected by the SRL at all. I'll just note that figure of public transport going up by about 1% because I'll come back to it in a minute. Building up the table, adding in the average daily distance walked, up about 4.5% compared to the 11 in the targeted subset. And again, the average by the people who do walk isn't changing, so this is more people walking rather than people walking further. And the same story again for all people, for the average daily time in active transport, up about 4%, more people spending more time in active transport. Finally, let's look at the geographic spread of the public transport benefits. You'll recall I said that the overall increase in trips with some public transport use was about 1%. So this map shows how that increase is divided up based on the local government areas where people live. Interestingly, benefits aren't just concentrated around where the SRL is located. There are increases in all local government areas spread over the city from about 0.5% to about 2% in each local government area. So this suggests the SRL is an effective network improvement, not just an uplift in localised transport. It's able to produce citywide benefits. And finally, just a reminder, going back to some of the modelling assumptions Mahsa talked about, these results are only as a result of the addition of the SRL itself. They don't include supporting changes in those other things there, population changes, job destination changes, changes in density and land use, improvements in bus connections. Those are all things that you might expect and hope would also increase uptake further. They're things we would hope to model in future work. What we would see is a breakdown of the outcomes attributable to different components of an overall plan. And with that, I will hand over to Dr. Lucy Gunn, Senior Research Fellow, who'll talk about house prices, affordability and walkability. Mute.
Thank you very much. So yes, just as Steve said, I'm talking about house prices, affordability and walkability, and seeking really to establish whether it's out of reach for some. This work was based on a publication that's been recently accepted and released, and it can be found through Cities and Health. It's open access, so if the work is of interest to you, you can download it. It's really seeking to ask this question as to whether there's value associated with walkability and does it differ by levels of disadvantage. With this work, I'd like to acknowledge my co-authors, which is Tayyaba Sagapur, Billie Giles-Corti, and also Gavin Turrell. A key aspect of this work that we were looking at is the knowledge and know-how that cities are socio-spatially patterned. And as you can see here on this particular map, it's really showing that the northern section and western section and also the southeastern section are more disadvantaged than some of the central sections of Melbourne. What we also know about these kinds of about the built environment is that there's an inequitable distribution in walkability. So this particular map on the right-hand side is showing that there is more walkable areas in the inner city areas, but that declines as you go further and further out towards the outer suburbs. Walkability itself is a useful concept for us to measure in the built environment because it's looking at where people are located, their ease of accessibility in terms of block sizes and street connectivity, and looking at how they can get to destinations. And when you put those three aspects together, you get what's called a walkable environment. More walking, of course, has health benefits, but it also is helpful in terms of getting people out of their cars because cars contribute to road network congestion and air quality issues. So in looking at this work, we were seeking to answer the main question, which is whether walkability has any influence on house prices. And one of the methods for establishing that is through hedonic pricing models. So this equation that you see here is very typical equation used in hedonic modelling. And what it's seeking to do is look at the house characteristics and location, but for us really focusing on the built environment. And for us, that was the walkability variables themselves. What was innovative about this work is that we looked at this equation according to strata of disadvantage, and that the disadvantage strata was based on the CEFA index. Hang on a minute. There it is, CEFA index measured by quintiles of 5 quintiles. And we also looked at 3 versions of the model. So we looked at a walkability composite score, and that has 3 things within it. So our first model was just the composite. The second model was looking at the population density, street connectivity, and access to destinations separately. And then we also looked at another model that had public transport in it as well, but I won't talk about that today. With this model, we sought to establish whether there was premiums or discounts associated with the walkability composite score. So I might just jump across to the results, and what we found when we're looking at the walkability composite score is that there are positive associations that were significant with house prices. So what this implies is that there is potentially a price premium associated with houses that comes from the walkability composite score. And what this implies in this particular case is that, what this implies with this particular case is that there's around, if I just look at the very first strata of disadvantage, the Q1, we have a value of 11.42. And what that means is that there's $11,420 worth of value that comes from having an average level of walkability for the most disadvantaged strata. Now, in comparison to the remaining strata, that's a little bit lower, and that implies that houses in the most disadvantaged areas are a little bit more affordable. But part of our analysis actually wanted to understand how the components of walkability would impact house prices as well. And so when we break it up by those components of population density, we find that population density is also positively and significantly related to house prices, but the values are a little bit lower. So just looking at that first strata, the value of 6.24 means that there's around $6,240 worth of value going towards your house price if you live in a disadvantaged area. When we move on to looking at street connectivity, the coefficients are a lot smaller, so there's not a lot of value coming from street connectivity. It's still positive and it's still significant, but we also find that there's some negative numbers in there, which implies that there's both a positive and negative effect. So the findings are a little bit mixed when it comes to street connectivity. When we look at the daily living score, and this is accessibility measured in terms of access to convenience stores, for example, or public transport stop, we find the biggest effects. And this is really a very large set of associations. So in terms of the numbers, it's around $32,000 worth of value if you live in a disadvantaged area. So having amenity is very, very important when you're talking about how that influences house prices. Now, these models can be used to predict, sorry, the dog is just nagging me, just a moment. It's very distracting, my apologies. So with the modelling work here, we wanted to get an understanding of whether there was a premium or a discount associated with house prices. So in terms of being able to do this, we used our first model, which has a composite walkability score in it. In order to get a value to put into our model, we had to look at the levels of walkability for each strata of disadvantage. Now, obviously, each strata of disadvantage has different levels of walkability. So just to get one number to be able to put into our model, we actually broke the walkability down into quartiles. So when you do that, that enables you to calculate out a price premium or potentially a price discount. So that question of whether there's a premium or a discount is something that we could answer, and we actually find a bit of both. So on this next slide, I'll show you what we have is that if we're just looking at the top and the bottom quartiles of disadvantage, we find that there's a bit of both premium and discount occurring. So in the for both disadvantaged and least disadvantaged areas, if you're looking at the bottom quartile of walkability, so this is where walkability is perhaps a lot worse than other areas in those disadvantaged strata, that's where you're getting around 5% discount in house prices, or if you're in the least disadvantaged area, it's around 1% discount in terms of the house prices. But when you're looking at higher levels of walkability, you actually get a price premium. So this is telling us that you have to pay a little bit more potentially. Walkability itself is valued more positively, and hence you get a positive price premium coming from walkability itself. So what does this mean in practice? What are the implications of this? If we wish to value walkability and its components, we're generally finding that there's a price premium, but that just depends on the extent of disadvantage and the level of walkability. For the disadvantaged areas with low walkability, there's a price discount in general. So what this is telling us is that in those disadvantaged areas, there's less walkability, but that means to some extent that the houses are a bit more affordable. But what that also means is that they do not have access to the key aspects of walkability that make it easy to walk. So having high population levels of density, having better street connectivity, having access to those destinations that really matter. What that implies is that there's costs that come out in different ways. So other research that we drew upon as part of this project was looking at the lack of other authors find that there's less quality time spent with family. There may be less time for physical activity, which then affects physical and mental health. And then it may be the case that you need a second car in order to get to your jobs and do your daily activities. So in essence, there's a set of costs that get externalized back onto households and families, which comes from not having access to walkability. So this is really just to summarise this, that walkability is not necessarily commensurate with housing affordability, because there is a price to pay if you want to live in a walkable environment. And this also highlights the role of planning, because planning itself can rectify these inequities in terms of the quality of the built environment. So we could plan for more walkable areas. We can also retrofit those that are not walkable enough. But we can also take a different approach and use inclusionary zoning to take people who are perhaps really need to have access to destinations and put them in areas that already have walkable environments. So at this point, I'm going to wrap up this presentation and just say a very quick thank you for all of the presenters that came before me. And I'm going to move on to another short presentation, which is really to talk about where the research is heading going forward. So what comes next? So I'd like to start off with the Transport Health Assessment tool. This is something that we developed in the last couple of years. It's essentially a tool that's freely accessible, and it can be found in the Australian Urban Observatory. But this tool takes short car trips and it replaces them with walking and cycling, and then it looks at the health benefits that come from that. The tool provides metrics on 7 different types of chronic diseases, and it also presents health benefit information in terms of life years and health adjusted life years. Now, this information can be used for evidence-based planning, but also for advocacy purposes. The tool itself recently won a Planning Institute of Australia award, both a state award last year and a national award this year for planning research excellence. Can be found on the Australian Urban Observatory, and that can be found under the Impact tab and looking at the Transport Health Assessment tool link just there. I'll just quickly move on to the Australian Urban Observatory. So you've heard a little bit about this already through Carl and through Billie, through the work of the team, but this is another excellent place for finding additional spatial maps and also metrics on 9 domains of livability. And the domains of livability are just listed there. That includes livability, walkability, social infrastructure, public open space, food and alcohol environments, employment and housing affordability. You can see the 2 contacts there, information on Melanie Davin and Catherine Murray if you wish to learn a bit more about it. And just this week, they've released some new different tools and also indicators which might be of interest. So they have comparison maps with 2021 census data, and also some new indicators looking at access to GPs in terms of distance to GPs and distance to general practitioners who bulk bill. Now, in terms of some of the work you've seen today, you'll have seen that Afshin's presented on agent-based and activity-based models. There's still a lot of work to be done in this space. In particular, we'd like to start looking going forwards at including things like more different types of land uses, employment, potentially joining up our models so that we can measure co-benefits, and in particular relating that back to explicit measurement of health. So Afshin Jafari is leading a lot of this work, and he's seeking additional funding to help build on what has already been done. And finally, I'd like to discuss a little bit about the JIBE project. So the JIBE project is a joint project between our research team here in Australia, but also a variety of different researchers in the UK. So that is being funded by the NHMRC and also the UKRI, and it's a project that's looking at joining impact models of transport to the built environment. In this project, there's going to be a couple of case studies, one of them looking at Manchester, one of them looking at Melbourne. We're looking to measure area-based measures of the built environment and route-based measures. We're looking at how that impacts transport mode choices, and we're feeding that back into health impact assessment modelling that factors in air and noise pollution and also injuries and accidents. So at this point, that's really where we're heading in terms of future things, and I'm going to just once again thank all of the presenters and the team and hand it back to you, Billie.
Thank you, Lucy. That was great, and that gives you I hope it's given you a bit of an overview of what the sort of work that we've been doing over the last 2 or 3 years, and opens us up for a panel discussion. So it's a great pleasure for me to welcome our panel. We have Sandro Demaio from the CEO of VicHealth. Sandro is a medical doctor, as many of you probably know, and is globally renowned as a public health expert and advocate. We've also got Sara Stace. She's the Director of Cities at WSP. This is a consultancy that looks at, an engineering consultancy, looks at sustainable engineering solutions for future societies that create a better future for society. So welcome, Sara. And then we've got Prue Smith. It's great pleasure to welcome Prue. Prue's the Manager of Urban Design at the Suburban Rail Loop here, which we've just heard a little about. And she's an urban designer, landscape architect, and a passionate Melburnian with over 25 years of experience in the design industry. So welcome to all of you. Now I'm going to take off the sharing of the slides. Can we just take that off, Lucy? Can you just stop sharing slides, and then we'll just have the panel up. Okay, so I think what we do is we'll get started. So Sandra, I'm very keen to hear from you. You've seen this sort of overview of this sort of work. It's just like it's just a small snippet of an insight into what we've been working on. I'm just wondering, from VicHealth's perspective, from a health organisation's perspective, what you see, what you've seen, what's your response to the outcomes of this sort of project, and what can you see in terms of taking this further in terms of, you know, future work that would be useful from a health perspective?
Yeah, thanks, Billie. I'll start by just acknowledging the land that I'm on here in Melbourne, the traditional owners of the land, the Wurundjeri people of the Kulin Nation, and acknowledge any First Nations leaders who are tuning in around Australia. I'd also, Billie, like to acknowledge your leadership and, you know, very long-standing leadership in this space, globally respected, and of course of the institution that you represent. As an agency for us, really, I mean, I was reflecting as the speakers were presenting, and as I was reading some of the pre-reading, and, you know, in many ways this can't be more timely. And four, I think, key reflections emerged from me. First is just, you know, once again reinforcing one of the tough lessons of the last 2 years, the importance of data and the importance of fit for purpose, timely, and in many ways real-time data, but also thinking about data sources that are non-conventional, looking at, you know, the use of ambient or location or other forms of data that we're able to access and that you so effectively are using to really inform public policy. So that nexus, you know, moving away from the days where we collect data and 4 years later that data pops out as a report that's 900 pages long, and then takes all of us bureaucrats another 12 months to read, digest and interpret, but actually providing real-time insights and very practical, I think, outcomes-based insights in a timely form. So the importance of data really emerges, I think, in proximal, real-time and user-focused data. The second is, of course, you know, the continuation of a global movement that we've really seen over the last decade of the rise of place-based and particularly city-level governance and leadership. And there's this kind of magic mix, whether it's climate change, whether it's food systems, whether it's social justice issues. There's this magic mix that has emerged and has really become almost a key part of the push towards the SDGs, more so than national leadership. And that is, of course, you know, the city-based governance and leadership. And it's the mix of, you know, the governance being more proximal, more transparent, more accountable, the political economy being, you know, in some ways slightly simpler. I don't think simple is the right word, but certainly, you know, less intractable. But also, you know, the greater granularity of challenges and insights that you know that have emerged and that we're seeing once again, I think, permeate through this important research. Cities, you know, rising really, I think, as a kind of scale of catalytic importance. The third is sort of, for me as a policy, as a person in policy and as a person leading a government agency, it still strikes me and disappoints me the lack of understanding, tangible understanding of the links between climate change and health. And I do think that it's important research like this that looks at the built environment, that looks at the structural determinants, that looks at things like, very practical things like public infrastructure, roads, things that government can clearly understand and touch, and has always been part of the kind of language and sphere of influence of traditional bureaucrats, even in the health field, that we can actually start to really tangibly tell the story of the links between climate change and health through things that are familiar to existing governments and governance. So I think there's a really strong and important role for the research that you're doing to continue to play in really building out the narrative, but also the opportunities, the co-benefits, and therefore the shared responsibilities across traditional silos of government and across generations of leadership as this important and urgent issue of climate change and its links with health. Of course, it's linked in every dimension with health, both planetary and human, continue to emerge. And I think the fourth is just the timeliness of this research. As we look to kind of build back fairer and healthier, we can't return to the 2019 world that we had. There's been enormous shocks in our system. Once again, I'm sitting at home today, calling in from my home spare bedroom. The world has completely changed. And I think understanding the challenges, the urgent challenges and opportunities, but also the tangible pathways to a fairer and healthier society and built environment is so critical, obviously, in that. I just can't help but read, as I listen today and also read the materials that you sent through, think how critically timely this is. It is really about recalibrating our compass, our societal compass, of where we head next as a nation and as a state through recovery. And I think, looking at ways that we truly physically build back healthier and how building back in certain ways with massive investments in infrastructure and others that are flowing through at the moment, how those can more tangibly be health investments, not just infrastructure investments, as well as climate change and health investments, to me is really, really exciting. Very, practically, we are working on a new multi-year strategy as an agency. And I think this work also is just very helpful for me in thinking through, what are some of the gaps in our work over the last decade and where do some of the major opportunities and risks lie in terms of getting the best possible impact to Victorians from the dollars they invest in our agency. So once again, thanks for your leadership and the opportunity to provide some reflections today.
Thanks so much, Sandro. I think you've given us a few clues there. It's interesting about this timeliness. It's taking us like 2 years to create this platform, the platform. And I think what we've got now, though, is an amazing platform through which we can answer questions. It takes a lot. It's once you've got it, it's good in it, but it still takes a lot of work. But you can actually, I think it's a real opportunity to capitalize on it. And I think you've given us other clues about what we should be looking to include is, the emissions that'll come from changing. Once we do these changes to the built environment, which is what we've done, is set up a platform where you can actually start to trial different interventions, is that we should be adding in not just the direct health impacts, but the environmental impacts and what those emissions changes will produce from, shifting 50% of people who were in cars now using the SRL. That can't be a bad thing. So I think that's something that we need to be building into our work. So I think that was really useful feedback. And we would love it if VicHealth decided to prioritise this area, because it's really always hard to get funding for this. And we do thank the Prevention Centre for their support. Now, I'd like to hand over now to the microphone to Prue. Because Prue, you're the urban designer at Suburban Rail Loop, and we're particularly interested into hearing from you. What's your reaction to what we've been able to create here, and by adding a health perspective to the work that you do, and if you can see any important steps that we should be taking in terms of advancing this research.
Yes, thanks, Billie, and thanks, team, and thanks for having me here today. Now, look, it's incredibly important work. Like, I think health considerations are just so critical for us, just to build our understanding and just make sure we're making really evidence-based decision making, particularly when we're looking at delivering on sort of Plan Melbourne's vision for 20-minute neighbourhoods and creating actually great places where people choose to live and work. I mean, that's fundamental to what we're doing. A transport project on its own is not enough. But I just want to start also by probably mentioning a bit of a challenge I guess we're all grappling with, and particularly urban designers in particular, is that Melbourne's got a massive challenge before it. We're like a really fast growing city. I think we're estimated by 2056 of reaching 9 million people, which is the size of London today. So, I mean, for this challenge, we've really got to look at how do we get people spending less time commuting, more access, jobs closer to home, which is part of that challenge, and improving people's mental health and providing more personal time, and just creating greater sort of greener places. Like I said, where people would like to live. But looking at this data, it's actually quite encouraging to see some of the shift in mode shift to active transport. I think with looking at SRL just as a rail project, it's actually only part of the story for SRL, a very important part of the story, and probably a catalytic part of the story. But in order for us to reduce sort of car dependency, increase active transport, there's actually a lot of other measures and suites and interventions we need to be looking at. And even with the rail project itself, it is more than the rail project. It does actually include a lot of cycling upgrades. It's got some, we've got creating higher amenity streets around the proximity to the station itself, as well as new public spaces, road closures. I think we've got over 4 kilometres of upgraded cycle paths and 11 kilometres of footpaths. So there's actually a lot in the rail project itself that might also further shift the dial. But like I said, it's more than a rail project. This is actually an integrated land use and transport project. So in terms of future work for the team, and where you could take this further to further sort of maximise those health and wellbeing benefits, would probably be looking at things like also precinct planning and structure planning, because once the rail goes ahead, it'll trigger a whole structure planning process, which will then result in further improvements around cycling and walking enhancements, as well as permeability and sort of urban structure and movement improvements through those precincts, which is the 1.6 kilometres around each station. We'll also be looking at things like, opportunities for additional greening, more tree canopy to create cooler, greener streets for people to walk, and places for people to pause, as well as what's the role of green infrastructure and open space in supporting walking and cycling. There's also other things precinct planning could look at as well, which is approaches to consider managing demand for car parking, which could have a significant impact on walking and cycling. And obviously, structure planning also needs to consider land use changes. What sort of additional households we will need around the station areas, and also the land use changes that will support increases in jobs, which will actually allow people to live and work close to home. So land use planning is absolutely critical. That's probably I don't know whether that gives you enough to work with, Billie.
I think that's fantastic. I hope Sandro's listening to this about a priority for funding. I think these are sort of really important, because what I love about what you're saying, Prue, is you're talking about just of what we've been trying to promote, this idea of the need for integrated planning. It's not just transport and planning separately, it's actually integrating that and getting the land use and transport outcomes that we really need, including demand management, so that you're trying to control the amount of driving that goes on in these precincts, and as a result of that contributes. It's actually to change the way to get the outcomes that we're seeking does require that integrated approach across levels of government, and that's exactly, I think, what you're trying to achieve with the Suburban Rail Loop. So thank you for those clues. I think that's going to give some really great fodder for future modelling. Now, Sara, you work in the private sector, so I'm very interested to hear from your view. You're a long-term advocate who's worked for many years promoting walking and cycling, and now it's wonderful to see you in the cities program for your organisation. So tell us, what do you see is the potential of all of this, and how to involve multiple levels of government, and what strikes you about the results and the findings that would support the work that you do?
Yeah, absolutely. And I'm joining today from Sydney, from the land of the Gadigal and Bidjigal people. And thanks for having me on this forum. Billie, I also want to, like Sandro, acknowledge the huge amount of work that your team has done over many years to really get the evidence base that we need to have in government and in consultancy. So thank you. So I work and have worked for decades now at that interface between transport and streetscapes and urban design. And about 10 years ago released the federal, probably a little bit more than that, the federal government's walking, riding and access to public transport study. And I think it demonstrated that having the evidence base coming from the research sector and academia is really important to be able to get the methodology and data that we need to make good decisions, to make proper evidence-based decision making. And I've also since then worked in sort of all three levels of government and then in the private sector. And in every single case, it's really important to be able to come back to what is the best practice methodology, which you've demonstrated today, and data. How do we get access to that sort of important current data that's not just the census from 2016 or last year's, which will be a little bit odd data because it was done during COVID. So having that access to that sort of more up-to-date data, and that's more stitching together different data sources together into what does this actually mean, I think is really important. And the other thing is I've done around about $6 billion in business cases for walking and cycling infrastructure investment. And we've found consistently that health accounts for 60 to 70% of those economic benefits when we're looking at those business cases. And so that's really important that we understand the health components of those and really keep challenging that. And the Ministry of Health in New South Wales has undertaken some very significant work on that. I'd like to see that become more nationalised. I think that will at some point, but it's always takes a long time. We move at glacial speeds for these sort of evidence-based information and methods. And then I guess in the consultancy sector who advise governments, it's really important we have that access to data and methodology to make sure that we are building on best practice and not reinventing the wheel each time. Having that kind of shared platform and shared understanding of methodology, I think, is really important, because otherwise we tend to just revert back to systems and ways we've done things 10, 15, 20 years ago that doesn't serve us for the future. I'm going to throw down three challenges, I suppose. One is the economic assumptions that we use for doing business case investment, or looking at what do we invest in. And at the moment, we tend to require a 7% discount rate in economic business cases, which means it's very hard to value public health, particularly for children and for climate change mitigation, because there is no economic benefit after 30 years. I think that's a real challenge for us in the business case world. I think also that you sort of talked about agent-based modelling, and I think that is really, really important for us to move in that direction. Again, coming from working at a transport agency, our current transport modelling, which tends to be the strategic transport modelling, does not account for mode shift in walking and cycling because it's based on travel time savings. And so that's fundamentally two really big problems. So you present all this wonderful evidence, wonderful methodologies and data, but it doesn't make a difference in the way we do transport infrastructure investment decision making. And then the third challenge, I suppose, is this forum has been incredibly densely packed with really valuable information to answer those questions that I've just raised. And I guess the challenge is, how do you share the key takeaways about that? What do we actually do about this to turn it into actionable investment or changes in the way we do things?
Oh, thanks so much. That's really a rich fodder for future research there, Sara. So thank you very much. I think that's really helpful. I think the economic work is something that Lucy and Belen have been looking at a lot, as doing some more health economics. And I think we've shown with Lucy's shown with the THAT tool has been very popular. In fact, other cities now want to have that as well. So I think definitely that's an important area. I think the idea of, we're very fortunate that we work with the Prevention Centre, because they help us with the communication side, because what we've learned from our previous work that we've done is getting out the bite-sized pieces that can actually help with translation, and we've been quite focused on that. But we're just finishing our final report, and what we'll be doing is making that available for people, but we'll do a summary document that will go with that, so hopefully to get someone to synthesize some of these points. Now we're going to open up for questions now, or I'm going to, before I do so, I'm going to ask a couple of questions of our panelists about their one take-home message. But if you've got questions that you want to put in the chat, please put them in the chat, and Lucy's going to put those to our panel and to our team. So please don't hesitate to put your questions in the chat. So I'm going to hand over now to each of the panelists. I'm going to start with you, Sandro. From what you've heard today, what's your one take-home message that we need to be thinking about, both for those listening and for those who are, people on the team? So either one, you can either give a take-home message for both, or you can just tell us what's your one take-home message from participating today.
Yeah, thanks, Billie. I think it is, again, we need to even further lean into the role of structural determinants and place-based approaches in recovery, and as a core opportunity as we build back fairer within the context of the ecological disaster that we know is unfolding around us. So a bit of a long takeaway, but that's where my brain's been left.
Yeah. And I think, Sara made the point about, the last COVID, last census is going to be corrupted by the fact we had COVID, but that could provide us with some clues about, what the mix of working from home to reduce emissions through people working at home and that sort of thing. So I think we can make this work for us. But thank you for that take home. Okay, to you, Prue, what's your one take home from this session?
Other than how great is data.
We like that. We like that take home.
Yeah. And now look, I think this is essential work to forming our decision making. But I guess the key takeaway or take home for me is it's really encouraging to see the increase in active transport through projects such as SRL. But it also sort of strengthens to me that also how it's just we really need a holistic approach to how we tackle some of these problems in terms of integrated land use and transport planning. So it's really crystallized probably what we already fundamentally knew.
Yeah, and just the difficult thing is making it happen. So yeah, we want to use have our data help.
And how can you help us? Yeah, you can help support us in that. Yeah, fantastic.
Yeah. Now, how about you, Sara? What would you say is the take-home message?
Yes, I guess it's how we translate the valuable research that your team's done and the Australian Urban Observatory, and then turn it into those practical things to help people like Sandro and Prue with their work in government in terms of actually getting tangible things built or invested in or done to really help the communities out there.
Right. Well, that would be the whole idea of the Prevention Centre is about systems change. So that's music to their ears, because that's what we want to do. This research is designed to change the system. And so, yeah, it's about how do we make that happen. So I'm going to hand over to Lucy now. If you've got any other questions, put them in the chat. And Lucy's going to be we've got a little bit of time to ask a couple of questions. So Lucy, over to you.
Thanks, Billie. Okay, so we've got a question here from Richard Joseph, and he says that he works in healthy ageing and wonders if the research considered an increasing older population. And the second stage to that question was, how does this research on healthy livable cities align with the World Health Organization's age-friendly cities and communities framework? So I think this is a great question. I think I can answer some of it, and perhaps Billie, you could also answer some of this. Billie, would you like to go first?
So perhaps I'll start with the second part of the question, because that we're actually talking with WHO at the moment, both in terms of seeing we can use our indicators into the work that's been done by the World Health Organization, because they want to have global indicators of the sorts of things we've been talking about: walkable neighbourhoods, access to public open space, and they're also looking to see the extent to which it aligns with their age-friendly framework. So from my point of view, it definitely does. We've shown in other research. We've got a big study. Gavin Turrell in our group is doing a big study called Habitat up in Brisbane, and we find that the same things for an ageing population, that the sorts of things that we talk about, walkability, access to public transport, access to public open space, is equally important for an ageing population. It might be a change. We might need to change the buffers to be a bit smaller for an older population. But certainly there's nothing inconsistent with what we're doing that would not be age friendly. So yeah, very much aligned. There might be extra things that we need to consider for an aging population, and that's something that we should be embedding into our work as well. But certainly I don't think there's any problem with an age friendly agenda to the work that we've done to date, and we can expand that through Gavin's work. So Lucy, over to you.
Yeah, thanks, Billie. And I was pretty much going to say the same thing about Gavin Turrell's study looking at the habitat data, which is specifically looking at older people. It's a really nice data set because it's longitudinal, so it's tracking them across time. And we can actually evaluate how the built environment impacts their behaviour as they age. And I think this is pretty relevant for all of us because none of us are getting any younger. We might move on to another question. And this one was, I won't go through the whole description, but we do have something from Jenny Pry, who was looking at some of the AUO data. And there was a key question there, which was, can the AUO generate tailored profiles on request for councils? And I think the answer to that, the short answer is yes, they can. The best people to get in touch with is Catherine Murray and also Melanie Davin, because they can assist you with some of that. We do have another question, and I think I'm going to handball this one over to Afshin. So if you wouldn't mind putting your camera on, Afshin. This is from Jeffrey Robinson, and he is asking that in modelling the transport movements associated with the SRL, Suburban Rail Loop, was any account taken of folk who would take their bikes on trains, and should we be looking at making it easier for commuters to bring their bikes on commuter trains?
Yes, I think that's a very important and interesting question, particularly for those living in outer suburbs, because yeah, we talk about cycling to work and destinations, but those who are living in outer suburbs, that's very hard for them to do because there is no destination within, no work or major destination within their bikeable distance. There are, but maybe not that much variety. So in the SRL intervention work, the only thing that we looked at was walking and driving. So cycling specifically was not included, but integration of cycling with public transport or particularly train, and also bike cages that you have in train stations. And another potential intervention is to provide good infrastructure for cycling around public transport station in outer suburbs. These are all key important questions that we are keen to investigate in future, but yeah, not in this study.
All right, thanks, Afshin. Now we don't have any additional questions at the moment in the coming through the chat, so I do encourage people to put in some questions if they have something quick that they would like to answer. Billie, do you have any questions that you might like to ask the researchers or the panel?
No, not at this stage, Lucy. I think we're getting close to wrapping up. So perhaps if there's no other questions that people would like to ask, perhaps I can just take over and just wrap us up. I'd like to thank so much the panelists for joining us. It was really fantastic to get your insights into what you think of what we've done. It's been a major program of work, as you can see, and I'd really like to thank all the team who have contributed to this work. There's others in the team who didn't get to share, but to everyone in the team who has contributed, it's been a huge team effort to get to this stage. we've really focused, most of my career has been focusing on the what and the why, and it's such a thrill for me to hear, Prue and Sara in particular, because you're not health people. I'll expect this from Sandro, but not from you, to say how important the health perspective is. I've spent most of my career trying to get people to take it seriously, and when I hear people outside the health sector talking about the importance of health, it just makes my heart sing, to be honest, because it's been a long time to get to this. So I'm really thrilled. And I think where this team is going now is to not just think about the what and the why. I think we've got that. We don't need to do that so much. We need to work out the how. How can we do research that can help you to achieve what we all know is important, particularly from the point of view that Sandro has just given us. We've got a climate emergency. We really need to transition as quickly as we can. How can our research help that transition and help you and give the wind beneath your wings to make that happen? So with that positive note, that's what we're trying to do, and we really appreciate the feedback you've given us. I think the team will really appreciate that for thinking about the next steps for their work. But thank you everyone for joining. It's been a great session, and thank you so much to the Prevention Centre in particular. We're so grateful to the funding. It's not possible unless we have funding, and it's been a wonderful partnership that we've enjoyed being part of the centre. So thank you everyone. Off to lunch, and thank you. Enjoy the rest of your day. Okay, bye for now.